Okay, so in the previous lecture, we started the discussion about lecture number 3. Here we talked about the initial concepts of cooperating process. So where we try to understand that when there are number of process, sometimes they have to cooperate with each other. The basic idea about cooperating the process is to share the data with each other. So we understand in this lecture that there are many mechanisms with the help of that the process normally cooperate with each other by sharing the data, and we understand the convenience. So why do we actually have the cooperating process? I gave you the example of coming to the college by bus. So when we do that, there are many advantages of cooperating with each other. So information sharing will be easy, computation speed up, which means one process can be divided into many small process, and easily we can complete the job. And modularity is breaking the big project or say big software into small portions. Again, it will be easy and it will bring lot of convenience, which means easily we can complete our job. There are many advantages of cooperating the process. So when we have the cooperating process, we understand that they do share, they do communicate with each other. So there are two models of communication, inter-process communication. One is with the help of shared memory. Second one is with the help of passing the messages, message passing system. Okay, so I explained to you what do you mean by sharing the memory. There are some system calls. I take you back to the system calls, which is lecture number 2. We understand anything we have to do with the help of a hardware or the computer to perform the important activity that is through the system program or the system call. Now, what is this memory map family of system call? What you need to remember, there are some system calls. The details are not given here, and also we are not going to get into the details now. Once we go to lecture number 7 and 8, we'll discuss there what is memory management. Okay, with the help of some system calls, the process can cooperate with each other by sharing the portion of the memory. So this is the memory of process 1 is shared with process 2. So how this link has happened? With the help of memory map system calls. Okay, so that we'll discuss later. Another method of sharing the data is with the help of pipe. I told you with the help of this pipe sign. So a buffer will be created or a memory will be shared between two processes here. What is the process? One is GREP, which is the searching process. Search the word party from the file. Events.txt is a file. It will search something, and then the result of that will be into the memory, and from this memory the result will be printed onto the printer. So LPR is one process, GREP is one process combined with the help of a pipe sign, which is explained in the explanation here. Now I did not discuss about threads. Now we are going to discuss about the threads. Threads is normally a concept supported by Java. Java. So operating system supports a concept called thread. What do you mean by a thread? It is a kind of a process. Process. Now, when we talk about a thread, a process can be a process can run have or a program can have number of threads. I will show you the picture and then come back to the explanation here. Let's look at this picture. I will go back to the explanation later. First, let us understand this. If you look at this, when we have the program, the code segment is actually our program. Our program. In that, we can create multiple threads. Example here, this is thread 1. This can be thread 2. This can be thread 3. So we can have a thread, which means in one program, we can create a portion which will run one thread, second thread, third thread. Okay, so we call this thread as lightweight process. So we call this thread as a lightweight process. Why do we call a thread as a lightweight process? We know the meanings. Lightweight means it is very light. Heavyweight means it is very heavy. What do we mean by lightweight and heavyweight here is, suppose this process, for example, this is process 1. Okay, if you want to load this process into the memory, okay, understand my point. Okay, so this is process 1. If you want to load this process into the memory, so we have to load the whole code. Okay, so I'll say, for example, we want to put the process into memory. We need to load the whole PCB. Remember PCB from the last lecture? Process control block, the code section, data section, process stack, okay, housekeeping information, memory management information, accounting information. Remember PCB we discussed in our lecture number 2. The whole PCB, should be loaded into memory, which means it is going to take some time to load this process into the memory, which means lot of information we have to load. Suppose this is process 1. Okay, now we want to remove process 1 and we want to load process 2. Okay, so this is process 2. Now, to remove this from the memory and to load this into the memory, it's going to take a lot of time. So we call process, I'm giving you a lot of explanation which we are going to read in the lecture. So process is called as heavyweight. Heavyweight. Thread is called as lightweight. Why we call thread as a lightweight, process as a heavyweight? Process is heavy because the whole process control block, what is the code, what is the data, memory management information, everything we have to load inside the memory. Now I will explain you about the thread. For example, now we have thread 1, we have thread 2, we have thread 3. Now thread 1 is working, for example. Okay, thread 1 is working. What will be there inside the thread? Only, if you remember, program counter. PC stands for program counter. Already we have seen in our lecture number 2. Program counter. Remember program counter? I told you program counter means in the program counter, in the program, in any program, there will be a pointer which shows which instruction it is working. That is called as a program counter. Okay. So for example, if you look at this example here, program counter 1, for example. This is program counter 10. This is program counter 20. Okay, now example, program counter 1, program counter 10, program counter 20. Now, thread 1 is working in the system. Thread 1 is working in the system. Now I want to run thread 2. Please note one point. This thread 1, thread 2, thread 3 are part of process 1. Okay, so thread 1, thread 2, thread 3 are part of process 1. That's why I put you this picture in the beginning. Okay, so process 1 is having thread 1, thread 2, thread 3. Now I want to change between the threads. Okay, thread 1 is working. Now I want to run thread 2. What normally we have to do? Just change the program counter. Okay, for example, program counter which is now working is thread number 1. Okay, so program counter number 1. Now I want to run thread number 2. So I put the names. This is thread 1, this is thread 2, this is thread 3. Now I want to run thread 2. What I have to do? Simply, everything is already in the memory. Understand? The whole process is already in the memory. I want to run thread 2. Just make the program counter to 10. What will happen? It will go to thread number 2. It will start working the thread number 2. Now I want to run thread number 3. Just say program counter is equal to 20. It will go to thread number 3. It will start working from there. What we have understand from here, changing between the threads is very fast, but changing between the process is very slow. Why? I told you, process is heavyweight process. The whole process we need to remove from the memory, and then we have to load the whole process into the memory. So imagine, instead of thread 1, thread 2, thread 3, we have process 1, process 2, process 3. Running them is going to take a lot of time. But if you do the same thing with the help of the threads, it is going to be very fast. Now we have a choice with us. Okay, so suppose we have a big program, we have a choice. Do we want to create 3 process 1, process 2, process 3, or we want to have thread 1, thread 2, thread 3? What is our choice is going to be, students? What is our choice is going to be? Do we want to create different process or do we want to create a thread? What do you think? Which is better? Which is better? From your understanding, is it better to create process 1, process 2, process 3, or in the same process we have 3 threads? Which is better now?
P1, process 1.
Process 1, which is having 3 threads, right?
Yes.
Okay, so just try to follow. So if you understand this picture, I will go back and read the definition. I will explain you what do we mean by thread and how do Java supports thread, what it is. So please understand, normally for the process, we have code segment, data segment, operating system, housekeeping information, memory management information, all these together, we call it as a PCB, process control block. But in the code segment itself, we have the code for thread 1, thread 2, thread 3. When we want to run the threads, just we have to change the program counter. So what will be in the thread? The thread will be having the program counter, the register space, and the stack space. So this is register, memory registers. We know already, the people who did computer organization, we know registers. And stack. This is also a kind of a memory, we keep the information. So register space, stack space. Now if you want to change between the threads, just we have to change the program counter. Now let's go back and read. You got the concept now. I will just read the official definitions, how it is. Okay, so what is thread? Operating system frequently supports a special kind of a process called thread to allow more complex data sharing. Now, actually, why do we have the thread? Because we can share the data together. If you look at the example, here, you can see the data. The data is now shared between thread 1, thread 2, thread 3. Because they are part of the same program, sharing the data is very easy because, they are actually in the same program. If we don't have that, if you have process 1 and process 2, sharing the data is going to be difficult because they need to have the special instructions for linking the data. Okay, so for data sharing, the standard process has got data section, code section, and the full process control block. That's what I told you. The PCB means store everything. The thread has got just program counter, register set, and the stack space. That's what we understand now. So here, code section, data segment, OS, housekeeping information, memory management information, accounting information, all together, we call it as a PCB, process control block, or the process information. But for the thread, only program counter, register space, and the stack space, only these three. So that's what the information about the threads. Now, we can have several threads within a single process using the same code section, data section, memory, and input and output resources. So that's what I told you. In a single process, we can create number of threads, thread 1, thread 2, thread 3, thread 4, thread 5. By doing this, what are the advantages? Okay, this is an example of a Java program. We still did not start the labs. I will tell you the examples later on, but just try to understand one example here. This is our main Java class, public static void main. Don't understand the code completely today. Just understand that in a process, there is a thread. Okay. Now, this is a thread class. Okay. Class A extends thread. So if you want to create a thread in Java, we need to create like this. Class A extends thread. Okay. Current thread is equal to thread dot current thread. So this is to get the information about the thread, to know the thread. Because we can create thread 1, thread 2, thread 3. To know which thread we are running, we can use this. Okay, so this is how we have some input and output, output some statements in the thread, and we run the thread like this. Don't understand the program, just understand there is a thread. Okay, so this is thread A, say thread class A. Now by using this class, we have created a thread. A is the name of the class. We created a child thread as new A. Now what happens here in this process? Child thread 1, child thread 1 is created. Now child thread 1 is going to start thread 1. Like that, if you want to run more than one thread, you can easily create in Java. Okay, now what is the purpose of the threads? If you ask me for some example to give, what is the purpose of the thread? Okay, if you look at, for example, we are doing a WhatsApp. Okay, if you look at our WhatsApp screen, I'm just giving an example. Okay, I'm not sure whether the code what they use is correct or not. I'm trying to give my own interpretation. Okay, so if I say, for example, in a WhatsApp, our WhatsApp screen will be like this. For example, here we see the messages. Okay, so I open a chat. Here I am going to see the messages. So I say in one WhatsApp program, this is one thread to get messages. This is a thread running to get the messages from the user. Now here we can type our message. So this is to send message. So another thread. So thread 1 is receiving the message. Thread 2 is sending the message. Okay. So in the same way, we want to record the voice in WhatsApp. Okay. So we click the button. Now what's happening here? These two are not closed. The programs are running. Now this thread is going to start T3 to record voice. Are you following me, students? Are you following me? The example?
Yes, Mr.
Okay. So in the same WhatsApp program, take the WhatsApp as one process, which is working in our mobile phone. When I open WhatsApp, internally to the WhatsApp, we can have multiple small portions will be working, that is created with the help of threads. So one is to send the message, one is to receive the message, one is to receive or to send the audio, and at the same time, say here, I got a video. So I click a button, play video. So what happens immediately, we know that it will start to play the video. A YouTube video or some video. So now for doing this, we can have thread 4. If you understand the concept here, depending upon the requirement, one process can have multiple threads doing different jobs at the same time. Remember, threads can work one after the other. Threads can work simultaneously also. You might be thinking, do we have to run one after the other? No need. All the threads can work at the same time. So T1 can be working, thread 2 can be working, thread 3 can be working, thread 4. Another example, thread 5. Like, in the message, we want to type the smileys, the icons, the emojis. So there will be another thread which will show you the pictures which you want to send into the WhatsApp message. Likewise, in a single process, we can create multiple threads and we write the code for the thread here. So like if you are seeing this example, so this is the code for one thread A class. Like that, we can create another for thread B, like another thread C or thread D. Likewise, we can call the threads in the Java program. So later, we'll try to see the examples in the lab. Now just try to understand the purpose of the thread. What do we mean by thread? Okay, so the thread will contain like this. So we'll have thread 1, thread 2, thread 3 working. Okay, we just have to change the program counter. So what is the terminology? Okay, the code segment, the data segment, and the operating system housekeeping information of a process is collectively known as a task, which means normally I'm using a word process. So you can say a process or a complete process. With all the information, we call it as a task. Okay, so a task with just one thread is called as a heavyweight process. Why? Because I told you it is just one single process. It is just one single process. We are calling it as a heavyweight process. Why we call it as a heavyweight process? I told you that if you want to change between process to process, this example which I told you already, changing between one process to another process, now this is the complete process information. It is heavy in the memory, so we have to load. If you want to change the process, we have to remove. It's going to be very heavy, so that's why we call it as a heavyweight process. But the thread, I told you, it is a lightweight process. Why it is lightweight process? I told you, just it is easy to change between the process. Okay, like we have understand the process in lecture number 2. The threads and process can do the same range of things. The threads can wait. I told you, we have seen the picture. The process can wait. The thread can also wait while the input and output process completes. Okay, the thread can be in different states. Like remember, the process can be ready. Here, the thread can be ready. The process can be running. The process can be terminated. But please note one point here. In the process, lecture number 2, I told you that when the process is waiting for input and output, we call it as waiting. But here we are not using this word. We are calling it as blocking. Please remember this change. Okay, for the process, we are calling it as waiting. Now this is not called as waiting, it is called as blocking. So that's why normally for the process can be ready, the process can be new, the process can be running, the process can be terminated, but the process is not blocked. The process was waiting. But now the thread, we are not using the word waiting, we are calling it as blocking or blocked. Okay, so like if you remember the last lecture, a process can create child process. Child process can create another child process. In the same way, the thread can create a child thread. Thread 1 can create thread 2, thread 2 can create thread 3. It's possible. So which means one thread inside another thread is possible. So a thread can create child threads. Like process can create the child process. We understand this in the end of lecture 2. What are the advantages of the threads? Already I explained to you. Responsiveness. Multi-threading, an interactive application may allow a program to continue running even if a part of it is waiting. So I gave you already the example of this is WhatsApp. So one part of the thing, you are waiting for the message to receive, but at the same time you can type your message. So two things can happen at the same time. Or maybe you are recording the audio, but still you are receiving your messages from your friend. So that's where it is responsiveness. Multi-threading an interactive application. What is interactive? There is a lot of interaction, input and outputs. May allow a program to continue running even if part of it is waiting. Okay, switching speed. I told you we can change the threads very fast. Switching between the thread is faster than switching between the heavyweight process because there is less to change. What is to change? I told you the example already. If you want to change between the threads, just you have to change the program counter. If you are running this, if you want to run this, just change the program counter. It will start to run. If you just change the program counter, it will start to run. But for the process, you have to load the whole PCB, like I gave you the example already. Okay, now communication between the process is very easy. We don't need any special setup for shared memory when implementing communication process as thread in the same task because they all share the same data. No need to make any special arrangement. Okay, already I explained to you that here we have the data. Now this data is automatically shared by thread 1, thread 2, thread 3. We don't need any special setup or a special link to make a sharing of the data between thread 1, thread 2, thread 3 because they are all part of the same process. It's also an advantage. That's why we prefer threads. Okay. What are the problems with the thread? Race condition. What is race condition? I will not explain now. Sometimes there will be a conflict. So I will just give you a brief idea about what is race condition. Okay. So one process or say one thread 1 want to write the data and thread 2 want to read the data. Okay, so if they are doing one after the other, it's okay. If thread 1 is writing the data and thread 2 is reading the data one after the other, it's okay. But first thread 2 is trying to read the data, but no data is available here, it's blank. So which means there is some problem. That is one example of race condition. One example of race condition. Another example. So we have a memory. Thread 1 want to write the data. Thread 2 also want to write the data. Now there is a fight. There is a conflict. Who has to write the data? Thread 1 is also trying to write the data. Thread 2 also write the data, because we have seen already thread 1, thread 2, thread 3, they are share the data, common data. Now when there is a common data, there might be a fight. Thread 1 is changing, thread 2 is changing. Now who is going to change the data? Okay, so there are some problems when we have multiple threads. Okay, so this point we are going to understand better in our lecture number 5, where we talk about process synchronization, what problems normally we face and how are we going to solve the problem. That is one point. Second point is we don't know which thread is going to work, because if you remember the kernel, I told you kernel is the important part of the operating system or the manager of the operating system. Kernel knows about process. Kernel knows about the process. Kernel does not know about the threads inside the process. I hope my point is clear. Kernel knows about the process, that okay, P1 is running, process 1 is running, but inside this process, maybe thread 1, thread 2, thread 3. It does not know. That's why sometimes we don't know and we cannot predict the behavior of the threads. It is very difficult. Also, for the same reason, it is very difficult to diagnose and test if there is any problem inside the threads. So what we understand, there are some advantages with the threads. At the same time, there are some disadvantages with the threads. We should know how to handle the disadvantages. Okay, now to solve this problem, which I told you that the kernel does not know about the process, the kernel does not know about the threads, they have introduced one problem, they have introduced one concept to solve some of these problems. So what is the solution they try to bring is, they divide the threads into two categories. They call some threads as user threads, they call some threads as kernel threads. So what do you mean by user threads? So the system does not know about that. Everything is managed by the user level libraries, which means the user only knows about the threads. If any unimportant work or a normal job, the user level thread is okay. But what is the kernel threads? It is supported by kernel, which means kernel knows about the threads now. Okay, so the user level threads, management done by the user level thread library. So they are the libraries. PYSIX is from the Unix or Linux, Windows threads, Java threads, kernel threads supported by the kernel. So virtually all general purpose operating systems they support. Windows, Solaris, Unix, Linux, Mac, they support kernel level threads. Okay, so what is user level thread? Implemented in the user level libraries without the need for the system call, which means user can run. If you remember last class, lecture number 2, we have discussed, we have application programs, which is done by the users, and we have system calls done by the system, and we have the kernel, and we have the hardware, same picture. So it is implemented by user level libraries without the need of the system call, which means they can work directly in the system. They need not to go for the system call. They can directly execute. Okay, they are very fast. Okay, but the kernel does not know about the individual threads within the process. And we understand if there is a problem, if there is a situation, there might be some problems if the kernel does not know. So this is user level thread without the knowledge of the kernel. Any unimportant work or a normal job, we can run like this. It's okay. To process something, to store something in the file, or to do some small job, we can do it like that. But the kernel does not know about the user level thread. Now, kernel level thread implemented with the help of a system call. Now, to implement this, the user has to send a system call. So, which means this system is not going to work. For everything, we need to have a system call. The system call, which means it is going to activate the kernel, which means everything with the help of a kernel. That is kernel level thread implemented via system calls. In this case, the kernel knows about individual threads, but because kernel is there every time, it is going to be very slow. Now I want to tell you one example which I already gave you. Okay, so I am the teacher. I will take you back to the same example which I gave you in lecture number 2. So here the teacher, I gave the same example in the explanation. Teacher, here it is dean. Okay, now for some jobs, the user level thread is the teacher is doing something. Here, who does not know about what I am doing in the class? Like I am taking a lecture now. I am taking a lecture now. So what I am teaching, which slide I am teaching, when I am going to do the quiz. So the dean does not required to know. So which means here the dean does not know about the individual thread, means individual class, what is going on inside my lecture. Okay, there is another way that for everything the kernel needs to know, which means whatever is going on inside the college, the dean has to know. If you understand this concept, if I have to make a change in the lecture, if I have to call you for the meeting, and if I have to conduct a quiz with the permission from the dean, everything is going to take lot of time, because first I need to take the permission from the dean. The dean should know what is going on from every teacher, every student, means it is very difficult. That's why the kernel level threads, they are slower, because to implement this, we need to do with the help of system call. We need to take the help of the kernel, and changing or switching between these kind of threads are going to be very slow. And here it is going to be fastest kind of a job. But if I do everything user level thread, there is no control in the system. Everyone can do anything in the system. If I do everything about the kernel, it is going to be slow. Now we want to get a balance. I hope you are following my point. If I follow completely user level threads, there are problems. If I follow completely kernel level threads, there are also problems. Now we want to have a balance. Now what we need to do here is, we need to have a kind of a mechanism called multi-threading. That point is not there. I will just give you some idea. Multi-threading models. So what normally we do, we completely don't implement kernel level threads. We completely don't implement the user level threads. We put some kind of a model called multi-threading model. So what we do in the multi-threading model, so there is one model called one-to-one. So one user level thread is connected to one kernel level thread. Now this is user level thread is connected to a kernel level thread. This is one model. We call it as one-to-one model. So for every user level thread, there is a kernel level thread. It is very difficult, because creating a kernel level thread for every user level thread is going to be very difficult. So we don't follow this model. Second model is, there we call it as one-to-many. Okay, so many to many. So there will be like many kernel level thread, user level threads are connected to many kernel level threads. So like, we don't have one-to-one, it's going to be like one-to-many. Okay, so this is one model. So like we can connect. Likewise, there are some multi-threading models with the help of which we can create some kind of a balance between the number of user level threads and the number of kernel level threads. So one-to-one, one-to-many, many to many. So this is a kind of one to many, and many to many, we know it's a kind of a multiplexing. So one kernel level thread, one user level thread will be connected to many kernel level threads. So it can be connected to this, and it can also be connected to this. So this is called as a many to many model. So there are many models, you need not to explain because it is not there in the lecture. So we understand that we understand that threads are very advantage in the system when we want to run cooperating process, and when we want to share the data, this is easy way of sharing. There are some problems in the thread because of the control of the system. So for solving that, we understand that user level threads and kernel level threads we can apply. Okay, so this is what is about threads and data sharing. Now there is another way of data sharing which we call it as message passing system. So what is message passing system is like, we are sharing with each other by sending the messages. Okay, so the mechanism for process to communicate and to synchronize their action. So what is message passing system? Process communicate with each other without restoring to the shared memory variables. What normally they do, no shared memory variables here. It's all going to be sending and receiving the messages. Okay, so one operation is send, another operation is to receive. So one process can send the message and receive the message. The size of the message can be fixed size or variable size. Maybe it can grow or it can shrink. So different type of sizes of the message. Okay, so how do we send the message? The pass message between the process with the help of a communication link using the hardware bus or the network or the shared memory must be established, which means we need to create the link between the messages. Okay, so send and receive the message. We'll see the example. Okay, so in message passing system, there are two communication methods. One is direct communication, other one is indirect communication. So what is a direct communication? Send name of the process, what is the message, send a message to process P, receive Q message, receive a message from process Q. Now if you can see this, there are two messages what we have seen, sending and receiving. So process 1 want to send a message to process 2. So what it will say, process 1 will say send a message to process 2, and this is the message. So the message will go to process 2. So process 2, how it will receive? Say, okay, receive a message from process 1. What is the message? So likewise, just we have two operations, to send and to receive. Okay, so what we need to do before sending and receiving the messages, we need to establish the link. So there will be a link between process 1 and process 2. A link is associated with exactly one pair of communication process, which means if process 1 is sending message to process 2, it cannot send a message to process 3 or process 4. Only one link will be established. A link is associated exactly with one pair. So process 1 to process 2 means it cannot send or receive from another process. So between each pair, there exists exactly one link. The link may be unidirectional, but it is usually bidirectional. What is unidirectional? So process 1, process 2, these are the two processes. Now we have a link. A link can be uni, which means only one direction. Either it can send or it can receive, but most of the times they say it is bidirectional. What do you mean by that? It can send, at the same time it can receive also. Two type of communication. Sending and receiving can happen at the same time. Okay, this is direct communication. Now, indirect communication. Now, normally I explain this with the help of an example. Okay, so in India, so when we send the post, okay, I just use a general example. So when we send a post or a parcel, in India, we have address system, a home address. Okay, so for example, I am sending a post or a letter or a parcel to my friend. Okay, so imagine this example. Remember this example. Okay, so A is sending a letter to B by using this direct communication. Okay, by using a address. Now what happens that B is not living in this address? Do you understand it now? My question. A has sent a letter to B by using the address, but B is not living there. What will happen to that letter? Will it go to B? Will it go to B? Do you understand my question here? A send a letter to B by telling that address that the B is going to be in this address, but B is not living there. B has changed. Can the letter go to B?
No.
No, Master.
No. So I hope you follow the point. Like for example, before coming to Sur College, I was in Rustak College. Okay, so some of my friends sent a letter to Rustak College telling that, okay, Mr. Hidayat is in Rustak College. He has sent a letter to Rustak College. But I am not in Rustak College now. I am in Sur College, which means I am not going to get that letter because no one knows that I am in Sur College, for example. So that is direct communication. So why we call it as a direct communication? Because we are sending the messages. Understand how the system works, sending and receiving. Using address. What is address in the computer or the name of the process in the computer? It is PID. Anyone remember what is PID? Anyone remember? We discussed in lecture 2, PID. What is PID? Anyone remember? PID. PID means process ID. Please remember this. PID means process ID. For each process, I told you that I shown you the example also in the last class. For each process, there will be PID. So process ID. Okay, I will show you the example now. I am running my system. Okay, look at this. Can you see the PID? Can you see the PID in my computer?
Yes.
So Google Chrome, the PID is 22416. Okay, so if I take PowerPoint here, for example, PowerPoint, the PID is 20828. So this is like the PID is like the address what I told you. PID is like the address what I told you. Okay, so if the process is going to send the message, okay, for example, Google Chrome, this is Chrome, is going to send the message to PowerPoint. It has to send the message like this. So Google Chrome is 22416 is sending the message to 20828. Okay, this is like sending with the help of a address. Okay, now I ask you one question. Think and tell me. This you don't have the idea, but I want you to guess. I want you to guess the answer. I close PowerPoint. Okay, I close PowerPoint. I open PowerPoint again. Do you think it will be having the same number, same address? Do you think the computer will give the same address if I open the PowerPoint again after closing? I did not explain. I want you to guess.
I think no.
No. So whenever any new process works, automatically the computer is going to send, or a computer is going to assign a new ID, new process ID. Okay. Now, what about this message? I send process 1, send this message to 20828. But now 20828 is not there. Like I gave you my example. I was living in Rustak. Now I am not living in Rustak, which means my address has been changed from Rustak to Sur. But A does not know that my address has been changed. So this is exactly the direct communication. There is some problem in the direct communication because Every time when the process is closed and the process is open again, it is going to get a new process ID. So I think you understand the problem. There is a problem in direct communication. So what is the problem in direct communication? When the process closes and opens again or restart again, it is going to get a new PID. So when we send the message or receive the message, normally here we don't write PQ or something. We write here the PID. We write here the PID, but PID is going to be changed every time. So which means there is some problem here in the direct communication. Now what is the solution for this? The solution for this is indirect communication. Now I come to the example of, I gave you the example of India. Now I am giving the example of Oman. In Oman, we don't have addresses, we have post box. I hope you know what do we mean by a post box. For the college or for the people, we can have a post box in the post office. Okay, which means if Hidayat has taken a post box, I will have a number 1233, for example. This is my post box number. It does not matter where I live in Oman. If I have a post box in some post office, my letter will go to this post office. Do you understand the example now? In India, we have direct address, home address in India. But in Oman, we don't have a home address, we have a post box number. When we send the letter to the post box number, it does not matter where I am living. It will go to my post box. What I will do, if someone has sent me a letter, I will go to the post office, means the post will not come like India to my home. I go to the post office, I check my box to see whether my letter is there or not. Do you think this is a good idea?
Yes.
So this is called as indirect communication. Now what is indirect communication? Messages are directed and received from the mailboxes. Like remember the example of a post box, which I gave you already. So post box. Okay, so what happens here? For each post box or a mailbox, it has a unique ID. Like I gave you the number. So for each post box, there will be a number like this: 1233, 1234, 1255. For everyone, or for there will be one ID. For a bank, for example, there will be one ID. So each mailbox has a unique ID. So process can communicate only if they share a mailbox, which means no PID, no process ID. They can communicate with the help of post box. So what are the properties of the communication link? Link established only if the process share a common mailbox. If they know the mailbox number, then only a link will be created. A link may be associated with many process, which means here I have a memory for the process. This is like a mailbox. Previously, if you remember what we have seen in the direct link, only one communication. Process 1 can only communicate with process 2, only one. But now process 1 is connected with this mailbox. For example, this belongs to process 2. Process 3 can also send the message. Process 4 can also send the message. So a link may be associated with many processes. That is one disadvantage. So each pair of process may share several communication links. Okay, so it may be one link to send, one link to receive, many links, no need to be one. And link may be unidirectional or bidirectional, like last time we have seen. It can be only sending, or it can be sending and receiving also. So this is indirect communication. So like you can see here, send a message. Send A is the name of the message box, and this is the message. Receive the message from mailbox A. So this is how we don't use the PID here, we use the mailbox. So mailbox A, which is the box, a kind of a post box between two processes for sharing the data, sending and receiving the data with the help of messages. Is that clear, students?
Yes, Mr.
Some operating systems follow direct communication, some operating systems follow indirect communication, but we identify or understand that indirect communication is a good way to communicate, because the messages are not going to be lost. Okay, so that's the end of the chapter. Okay, we'll take a break, okay, of 5 minutes. Then I will introduce you the next lecture concept, just to get an idea, because next lecture will take some time, and we need to understand some concepts. That's why I will just introduce some of the concepts of next lecture. I will not take the full lecture, just part of the lecture, and then the remaining part of the lecture we'll see in the next class. Okay, take a break of 5 minutes. After the break, when we come back, we'll just see some part of lecture 4. And lecture 4 is very important lecture. Okay, take a break.